Okay, so today we have two topics. The first one is applications of double integral, and the second one is calculating the surface area of something. The first part is just introducing you a lot of formulas, and there's nothing new in terms of taking double integral. And it should be simple, but it's just a lot of computation, so be aware of that. Oh, also, I'm not in my best. Uh, so I'm not feeling so good today. So if I made any mistake, please correct me. I think I made a few mistakes. Not a few, like one mistake in my last tutorial. So hopefully I don't do that. If you see any mistake, please correct me before the tutorial ends. So hopefully you guys are ready to do math. Anyway, today, first topic, application of double integrals. Electric charge. So if electric charge is distributed over a region D, and the charge density is given by sigma xy at the point xy in D, then the total charge Q is given by this formula. So yeah, it's basically it. You just need to use this formula to compute your total charge. So I'll give you 3 minutes to work on the first example. At 10:15, I will take it up. Alright? Okay, let's take it up. So basically this question is exactly like this. So electric charge is distributed over the disk. So this is your D. So now the charge density at xy is sigma xy equals to square root of x squared plus y squared. And then they ask you to find the total charge. So the total charge is given by this formula. So Q equals to double integral over D square root of x squared plus y squared dA. But if you look at the disk D, this is a unit square. No, not unit square, unit circle. Sorry. So x, y, and then it's everything inside the circle, including the circle itself. So this is your D. So if you look at this, it's really easy to do it using polar coordinates. So let's convert it to polar coordinates. So we can convert x squared plus y squared is less than or equal to 1 to polar coordinates. Where r is in between 0 to 1 and theta is in between 0 to 2 pi. Okay, then your sigma xy equals to square root of x squared plus y squared equals to r. So your q is 0 to 2 pi, 0 to 1, and then r. So r times r, which is r squared, because when you convert it to polar coordinates, is f r theta r dr d theta. So dr d theta. So this will give you 1 over 3 r cubed, r equals to 1 and r equals to 0 d theta, and that's gonna be that's 1 over 3 2 pi, so 2 pi 2 over 3 pi. No, 2 pi over 3, sorry. Okay, any question? How do we got the radius again? Oh, it's a unit circle, so it's a unit circle with radius 1. Here, it's r squared, so r is 1. Yeah, okay, move on. Now let's talk about moments of lamina. About x-axis and y-axis, basically you just need to use those two formulas, and this is helpful to find the center of mass of a lamina. So basically you need to find the mass first and then use what you found before to calculate your center of mass, which is x bar and y bar. Okay, so example 2 is pretty long. I'll give you how many minutes? I'll give you 8 minutes to work on this. So 10:27, and I'll take it up. Okay. Okay, let's take it up. First of all, let's calculate the mass using this formula. So m equals to double integral of d rho xy is xy, so xy rho xy dA. X is from 0 to 1. Y is from 0 to e to the negative x. And then xy dy dx, which will give you 0 to 1. And then xy squared over 2. Well, y equals to e to the negative x and y equals to 0 dx. And this will give you 0 to 1 x e to the negative x over 2 dx. And then you need to use integration by parts. Negative x e to the negative 2x over 2, 0 to 1, minus the integral from 0 to 1, and then negative e to the negative 2x over 2 dx. Okay, so this is 1 over 2 times negative e to the negative 2 over 2 minus e to the negative 2x over 4 from 0 to 1, which will give you 1 minus 3 e to the negative 2 over 8. So that's your mass. That's the first one, and then you need to find center of mass. So to find center of mass, I'm gonna calculate those two first. So mx equals to do you guys mind if I skip the calculation part? Oh, it's negative 2x here, sorry. Wrote it wrong. Here's negative 2x. This is right, yeah. Okay, so I'll write it down. I'll skip the calculation part so that we have time to do more questions, okay? So this is 0, 1, 0 to e to the negative x, x squared y, dy dx. So after your computation, you should get 1 over 8 minus 5 over 8 e to the negative 2. And my is similar, but instead of x squared, you have y squared. So it's xy squared. And after computation, you'll get... That's when you do center of mass. We're not there yet. Yep. So 1 over 27 minus 4 over 27 e to the negative 3. And then you can calculate center of mass. So that's gonna be 1 over 8, 1 minus 5 e to the negative 2 over 1 over 8, 1 minus 3 e to the negative 2, and then 1 over 27, 1 minus 4 e to the negative 3, 1 over 8, 1 minus 3 e to the negative 2. Okay, so you can cross out 1 over 8 here, and you can factor out e to the negative 2 outside, and then you can cross out. That's gonna be factor out, so e to the 2 minus 5 over e to the 2 minus 3. And here is 8 times. So factor out e to the negative 3 will give you e to the 3 minus 4 over 27 times e to the 3 minus 3e. Okay, so this is the final answer. Question? It's just computation. Okay. Do we have any question? I'm doing questions similar to your assignment, so hopefully it can be helpful. Okay. Seems like everyone's okay. So, moment of inertia about x-axis and y-axis. This is really similar to before. If you look at the formula, you'll see that when we calculate here, when we calculate those two, it's this. And moment of inertia is just y squared and x squared. Okay? And basically I0 is just you add those two together. So add those two together, you'll get this. I didn't prepare any question because it's really similar to center of mass. So if you can do center of mass, you can do this. The rest is just take integral. But I want to talk about joint density function because we have a homework question that's similar to this. So the joint density function of x and y is a function of f of two variables such that the probability that xy lies in the region D is this. In particular, if the region is a rectangle, which is most likely what it's going to be, the probability of x lies between A and B and y lies between C and D is this. So most likely you'll use this to compute whatever your probability is. And because probabilities are not negative and they are measured on a scale of 0 to 1, the joint density function has a following property. So whenever they ask you to verify if a function is a joint density function, you need to verify those 2 points. So you need to make sure fxy is greater than or equal to 0. And if you take double integral over r squared, it should give you 1. Okay? So those two are the ones you need to verify when they ask you to check if it is a joint density function. Expected value of x and y is just mu1 and mu2, where it's just double integral over r squared x of xy dA, and the mu2 is double integral over r2 y of xy dA. So as I said, there is nothing new, we just need to use those formulas to compute. So let's do example 3. This is really similar to your homework question. So let's try this. I'll give you 5 minutes, so I'll take it up at 10:40. You don't need to do all the computation because it's gonna be really ugly. And later you need to use the limits and everything. So stop where you can, where it's just 136 material. Okay? And then do the computation at home. 3A variation. Oh yeah. Did I forget part of the function question? Let me check. It should be, yeah, it's asking you to verify it. Verify that. Sorry. Verify that fxy is a joint density function. For the homework question, it says for 15 points. Oh, yeah, she told me about this. She said she's using... Which edition are you guys using? I'm not sure which edition you guys are using. 8th edition? Then she's using 9th edition. Yeah, so she told me she's using the newer edition than you guys. That's why she, instead of putting the number on the textbook, she's posting the question instead on quote mark. So you do whatever showed up on quote mark, just to avoid the confusion. Cause like some people, you just worry about homework one. It's okay. I mean, I'm marking homework one, so I'll make sure you're. I'll mark based on the question you are doing. Okay. The questions in quote mark have some typos though, like the expression is not showing up. Let me have a look. Find the expected value of math expression. Okay, I'll fix that later. I'll try to fix that later. I'll have a look and try to fix that. Yeah. Any other question? So you do whatever is showing up on quote mark instead of following the number in your textbook. Okay? Yeah, cause like some people were using 7th edition as well, so she'll just type out the question on quote mark and you do that instead. Okay, let's do this one. This one is a long one. So A, since it's pretty clear that f of xy is greater than or equal to 0, we don't really need to prove it. So we know that fxy is greater than or equal to 0. So we just need to check if double integral r squared and then fxy dA equals to 1. So that's why you need to check. So let's compute this. So r squared 0.1 e to the negative 0.5x plus 0.2y dA equals to, so 0 to infinity, 0 to infinity, and then this. And then dy dx. Okay, and this you can take out 0.1 and separate them, since here is e to the negative 0.5x times e to the negative 0.2y. So we can separate them, do dx and dy separately. So this will give you 0 to infinity e to the negative 0.5x dx, and then 0 to infinity e to the negative 0.2y dy. Okay, now you see that we have upper bound being infinity, which means you cannot compute it directly. So you need to do the limits. So you can write this as 0.1 limit as t goes to infinity, and then 0 to t e to the negative 0.5x dx, and limit t goes to infinity, 0 to t e to the negative 0.2y dy. Okay, and just compute this. I'll do the first limits completely, and the rest I'll just give you the final result. Okay, so this is 0.1 limit t goes to infinity, and this is negative 2 e to the negative 5, 0.5 t minus 1, and the limit t goes to infinity, 0. Not 0.5, negative 5 e to the negative 2t minus 1. So that, as t goes to infinity, this will give you 0.1 times negative 2 times 0. So this will give you 0. 0 minus 1 is minus 1. And negative 5 times 0 minus 1. So negative 10, that's negative 10 times 0.1 is 1. No, I mean 10. 10 times negative 1 is 1. So this verifies that is a joint density function. Okay, part B. Find the following probability. So you need to use this formula to compute this. So let's try that. So P of y greater than or equal to 1 equals to 0 to infinity, 1 to infinity, fxy dy dx. And fxy is just this. So I'm gonna replace this with that. So it's basically the same thing except you're changing bound. The dy dx, okay? So similarly, you can do this. Just change the bound. So 0 to infinity and 1 to infinity. And similarly here. I'm just copy pasting everything. Change the bound to 1 here. Let me see if I have any mistake. 0.1 limit t to infinity, 0 to t, this, and t to infinity, 1 to t, this. Yeah. And do the limits. So I'll just copy paste everything and change bound. We are here, so here. Copy, paste. And here should be, this bound is changing from 0 to 1, so here should be 0.5x minus here's, this is gonna be different. And everything else stays the same. E to the negative 0.2, okay? And this, that's 0, so 0.1 times negative 2 times negative 1 times negative 5 times 0 minus e to the negative 2. So this is e to the negative 0.2. Okay? And you should write it as decimals, which I don't know what it is. You calculate that yourself. The second one is really similar, so I'll let you do that. Okay, basically it's the same thing except you're changing the bound. So I'm pretty sure you can do that yourself, right? So instead of 0 to infinity and 1 to infinity, change to 0 to 2 and 0 to 4. The rest is just the same. So do the same thing over and over again. And lastly, the expected value. Oh, this I'll give you an answer. X less than or equal to 2, y less than or equal to 4. This, I'll write the first step. I'll change the bound for you and I'll give you an answer. So 0 to 2 and 0 to 4. Eventually you should get 1 plus e to the negative 1.8 minus e to the negative 0.8 minus e to the negative 1, which equals to something, calculate that yourself, okay? See, mu1 is double integral r squared, and on x times fxy dy dx, oh, dA actually, which equals to, so, which equals to this multiplied by x. So I'm gonna copy paste again because it's really similar. And then I'm gonna add x here. Oops. Okay, and you do the rest of the stuff yourself. Eventually you should get 2. And for y it's really similar, so mu2 is this except you multiply by y. So here should be y, and here should be y as well. And eventually you should get, it's pretty complicated, but make sure you do the work yourself. Make sure you know how to do limits. Eventually you should get 5. Okay, any question about this? Make sure you know how to do limits and integration by parts. Question? Question? Do we have any question? What was mu again? Oh, mu is the expected value. Here, go back. Here. I basically typed out all the formulas you need to know. So, yeah. I think I did at least. Yeah. Yeah, it's basically you're given a formula, you plug in numbers, and you do the computation. Just make sure you know how to do limits and integration. I mean, even for integration, even if you don't know how to do it, there's always integral calculator. I did not say that, but there is always something you can get help from, right? But still make sure you know how to do them, especially limits. Don't think you can get help for limits, right? Can you? At least I don't know about that, but there might be something. Oh, Wolf and Alpha. Oh yeah, Wolf and Alpha can help you. Yeah. So there's always something that can help you. Uh, which makes this course pretty bird. Anyway, at least for now. Area of surface. Again, you're just given a formula right here and just compute it. There's nothing new. Example 4, I'm gonna skip it because it's really simple. Okay, I'll just talk about it and you'll see how simple it is. basically you need to take the partial derivative of xy with respect to x and y. So your fxy here is your z, which is 5x plus 3y plus 6, right? So the partial derivative of this with respect to x is 5, with respect to y is 3, so 5 squared plus 3 squared plus 1. That's 35. So basically you're taking double integral of square root of 35 dx. So it's really simple. Eventually your answer should be 12 times square root of 35. Okay? This question is really simple, so I'm not gonna take it up since we are running out of time. Let's do example 5 instead. So I'll give you some time to think about it, but we don't have much time, so I'll give you 2 minutes to think about it and I'll take it up at 10:59. Okay? Oh my god, sorry, that was my dog. No barking. Okay, oh, it's past 10:59. It's 11 already. So basically, this question is pretty complicated because the integral is really ugly. This is your z. We find it by using this formula, and we know it's above xy plane, so you only have the positive part. And then no, z with respect to x, the partial derivative of z with respect to x is this, with respect to y is this. We need to find those two because this formula, okay? So we have this formula, we need to find partial derivative of fxy with respect to x and y. So I found those, now you need to compute them. So this square plus this square plus 1. Pretty complicated, pretty ugly. Square, so x squared, that's the same thing, so cross out. So eventually you get x squared plus y squared. And over, well then it's a squared minus x squared minus y squared plus 1, and then dA. Okay, that's set enough. Now you can tell that this is really complicated, and we know that the graph looks like this, so it's easier to convert it into polar coordinates. So if you want to convert it to polar coordinates to find your range of theta and r is simple, it's from 0 to a cosine theta, so dr d theta. So theta is from, it goes from here to here, so negative pi over 2 to pi over 2, and r is from 0 to a cos theta. And then let's convert this whole thing in terms of r and theta. X squared plus y squared will be r squared. So square root of r squared over a squared minus, if you add them together, that's r. So that's a squared minus r squared plus 1, and then r dr d theta. Okay, so you convert it into polar coordinates, simplify this, and do the integral. It's really ugly, so it's gonna take a while. I'm not gonna do everything. Square root of a squared minus r squared and dr d theta. Okay. The rest is computation that I won't do, but I'll give you the final answer should be a squared times pi minus 2. Okay, that's it. Any question? So as you can see, whenever you see something like a circle or part of a circle, something like that, you should convert it into polar coordinates, and when you convert it, make sure you times r dr d theta, and that's it. Not much. Any question? If not, that is the end of the tutorial. Good luck on your assignment, and I heard that you have a test next week. From my last tutorial, they said it's on Friday. I'm not sure if that's true, but you have a test next week. 11? Okay. So yeah, so you have a test next week. Your professor told me that she just want you to know the basic material. So she's not gonna be creative about the questions. That means just practice textbook questions, and that should do the work, I think. Well, based on what she said, if it's not creative with just basic material, then it's just textbook materials. Okay, so duly suggest the exercises, and hopefully that's good enough. Yeah. Bye everyone.